Welcome to 7.2 Multiplying and Dividing Rational Expressions. And that is our overall objective of this lesson. First thing we have to talk about is what is a rational expression? And it's a fraction whose numerator and denominator are polynomials. Now, we do have some steps for multiplying and dividing that we follow every single time. First thing we're going to do is we are going to factor, and you want to factor both the numerator and the denominator. Then we are going to identify undefined values, and that means we're going to set our denominator not equal to 0. Then we are going to cancel common factors that are being divided. Now, we have to remember when we are canceling, we can only cancel if they look exactly the same. So, a major warning here is x over x plus 5. We cannot cancel if there is just addition happening. It has to be multiplication. These x's will not cancel out. This is not equivalent to 1 over 5. Similarly, if I have x plus 10 over x plus 5, these x's will not cancel. We can only cancel when there is multiplication happening. That is the only time things get eliminated. So this is not equivalent to 10 over 5. Just be careful that you remember that throughout this process. So we are going to start with multiplying. Looking at number 1, the first thing I want to do is factor everything that I possibly can, both the numerator and the denominator. And this is where your factoring skills have to be really good because you can't spend too much time going through the process of factoring. So I need factors that multiply to be -3, add to be -2, and I need factors, which in this case would be x minus 3, x plus 1. And I need factors that multiply to be +5, add to be +6. And that's going to be x plus 1, x plus 5. Now, once I have factored everything, I'm going to identify my undefined values. And that means I'm going to take my denominator and I'm going to set it not equal to 0. And when that's happening, remember when we were solving by factoring, we set each factor not equal to 0. I get x cannot equal -1 and x cannot equal -5. And generally in our notes, we have a place for us to write our undefined values so you do not forget it. If you were to just box this in your work, that also is okay. Now, once I have done undefined values, then I can go on and start canceling things. You cannot start canceling until after you've written down all of the undefined values. So remember, there is multiplication occurring. I have multiplication of this parentheses times this parentheses times this parentheses. So I can cancel things out that look exactly the same. And it looks like I have an x plus 1 on the top and an x plus 1 on the bottom. Now, x minus 3 and x plus 5 do not look the same, so I cannot cancel them. And that leaves me with a final answer of x minus 3 over x plus 5. Remember, back to our warning, we cannot cancel out these x's. Therefore, we cannot cancel out these x's. Only when you have multiplication can you cancel something out. Okay, number 2. I have x minus 4 squared, which I'm going to go ahead and write as x minus 4 times x minus 4. I'm looking for something that multiplies to be 20, adds to be -9. Those factors are -4 and -5. Now I'm going to go in and write down my undefined values. So I'm setting each factor not equal to 0. X cannot equal 4. X cannot equal 5. Now that I have my undefined values and I have written them down in my blank, I'm going to go ahead and start canceling things out. Well, I have 1x minus 4 in the top, 1x minus 4 in the bottom. One pair goes together. I can't cancel this one out because there's not another x minus 4 in the denominator. So my final answer is x minus 4 over x minus 5. Looking at number 3. So we have a little bit more factoring than what we've done so far. First thing, I see a GCF of 2 in this numerator and a GCF of 2 in the denominator. That's going to give me 2x plus 7, 2x squared minus 25, times GCF of 8, 8x plus 5, GCF of 6, 6x plus 7. Now you have to be careful that everything is simplified completely. And if you notice, right here, x squared minus 25 is a difference of squares. So I need to factor this more. I factor it to be 2x plus 5, x minus 5. Once this step is complete, now notice I don't have a problem similar to number 1 and number 2. I'm not just dealing with one numerator, one denominator in this third question. But remember, the nice thing about multiplication of fractions is when I do it, basically, I get one big numerator and one big denominator. So I can go ahead and act as if this is one big numerator where there's multiplication and one big denominator where there's multiplication. Now, I'm going to set my denominator not equal to 0, and that means everything that is in this big denominator is getting set not equal to 0. Let's erase this so we don't get confused and think it's division. Now, x plus 5 means x cannot equal negative 5. X minus 5 means x cannot equal positive 5. X plus 7 means x cannot equal negative 7. The 6 and the 2 don't generate any undefined values. So my three undefined values are x cannot equal plus or minus 5 or negative 7. Now that I have my undefined values, I'm going to go in and start canceling. So remember, one big numerator, one big denominator. If there is anything matching top and bottom, I can cancel it out. First thing I notice, I have two 2's. I have 2x plus 7's, 2x plus 5's, and I'm left with 8x minus 5 and 6. So I'm going to go ahead and write that out. And I do have a little bit more simplification I can do. 8 and 6 can be simplified to 4 and 3, giving me a final answer of 4 over 3 times x minus 5. Now, number 4 is a lot of factoring because I have a's not equal to 1. So we're going to get some practice on how we should be splitting the middle. I'm going to focus on this numerator first. So I am trying to find something that multiplies to be 4 and adds to be positive 5. Well, those two factors are x plus 1, x plus 4. Well, no, x positive 1, positive 4. Sorry, don't want to confuse you because remember, we can't use a shortcut here. Now, I rewrote my middle term, this 5x, as plus x plus 4x. I'm going to group the first two terms together and group the second two terms together. Now, the GCF of my first group is x. GCF of my second group is 2. So that gives me x times 2x plus 1 plus 2 times 2x plus 1. And now remember, from our factoring refresher, my parentheses should match, giving me my common factor of 2x plus 1. I'm left over with x plus 2. Now the denominator is also another special case where I have a difference of squares, where a is my 2x and b is going to be 1. So I end up with the factors 2x plus 1, 2x minus 1. So I'm going to follow a similar process for this second numerator. I'm going to see I want numbers that multiply to be negative 2, add to be positive 1, and that's going to give me positive 2 and negative 1, which are the terms I use to split the middle. I group my first two together. I group my last two together. The GCF of my first group is x. And the GCF of my second group is just going to be 1 because there's not much I can pull from 2x and -1. Now remember, the goal is to have matching parentheses so that I can say my factors are 2x minus 1, x plus 1. And the bottom denominator is a classic shortcut problem. -2, we want it to multiply and add to be +1. Those two factors are x minus 1, x plus 2. Now that we've gotten through the factoring, which is the hard part on this problem, we're going to go ahead and set our, again, remember, we have one big, because there's multiplication, one big numerator, one big denominator. We are going to set the denominator not equal to 0. So from my first denominator, I got x cannot equal -1/2, x cannot equal +1/2. For my second denominator, I got x cannot equal 1, x cannot equal -2. Now that I have my undefined values written out, I can go ahead and start canceling things. I notice I have 2x plus 1s. I notice I have x plus 2s. I notice I have some 2x minus 1s. And I have x plus 1, x minus 1. If they do not look exactly the same, you cannot cancel them out. So I'm going to go ahead and say my final answer is x plus 1, x minus 1. Now that we have practiced multiplying, we are going to move on to dividing rational expressions. And the nice thing about when you're dividing fractions, so remember, when you're dividing fractions, we keep the first fraction, change the division sign to multiplication, and flip the second fraction. So you're going to hear me say a lot, we need to keep, change, flip. Keep the first, change it to multiplication, flip the second. The nice thing about this is we are going to change it into a problem like the ones we just did. So we just have to kind of work with the division for a small bit of time in order to transform it into a multiplication problem. So let's start with example 5. First thing, I'm going to keep the first fraction exactly as it is, x plus 2 over 8. I'm going to change the division symbol to be multiplication. I'm at the keep change. Now is the flipping point. I'm going to flip the second fraction so that the denominator is now the numerator and the numerator is now the denominator. So I've turned this division problem into multiplication. Now, the thing that is different and that you have to be careful of is, remember, we are creating one big numerator and denominator. However, we have to remember where we started. This term was in a denominator. And remember, we can't divide by 0 in any instance. So I'm going to set not only the denominators not equal to 0, but I'm also going to set the numerator of my flipped fraction also not equal to 0. The reason why I do this is because at some point in the question, it was in a denominator. So I have to set denominator, second numerator, not equal to 0. Now, with this problem, we do have some just constant values. 64 not equal to 0 isn't going to do anything. 8 not equal to 0 isn't going to do anything. However, from x plus 2 not equal to 0, I'm going to get x cannot equal -2. And now I can go on and start canceling things. So remember, most of these things we consider to be in parentheses because they are being multiplied. So I can cancel out my x plus 2's. That leaves me with 64 over 8, which simplifies to be just 8. Let's go ahead and look at number 6. Now, how you choose to do division, whether you choose to factor first or keep, change, flip first, is completely up to you. I went ahead and factored my problem in the beginning. Most people will do this as a combined step but I kind of want to take it slow in our second example. So x squared minus 2x minus 8 factors to be x plus 2, x minus 4. X squared minus 2x minus 15 factors to be x plus 3, x minus 5. This has a GCF of 2x, so I get 2x, x minus 4. This has a GCF of 2x, so I get 2x, x minus 5. Now that I have everything factored, I'm going to go ahead and keep, change, flip. I keep the first fraction exactly as it looks. I change my division to be multiplication, and then I flipped the numerator and the denominator of my last fraction. So keep, change, flip. Now that I have done this, remember, we have to think about where we began. I am setting the numerators. So remember, we have a big fraction now. Both denominators, sorry, and the second numerator not equal to 0. I always like to include this one here just so I don't forget. You don't have to, but just remember the whole denominator is getting set not equal to 0. So from my first denominator, I get x cannot equal -3, x cannot equal 5. From my second denominator, I'm going to get 2x. When I set it not equal to 0, that means x cannot equal 0. X minus 4 means x cannot equal +4. And I get similar restrictions. 2x gives me x cannot equal 0. X minus 5 gives me x cannot equal 5. Now, if you have repeats, you don't have to write them twice. So I wrote my undefined values as x cannot equal -3, 0, 4, and 5. Now that my undefined values have been written, I can go ahead and start canceling out things that look the same. Because remember, I've turned this into a multiplication problem. One big numerator, one big denominator. As long as you have a pair where one is in the numerator and one is in the denominator, you can cancel. So let's see. My 2x's go away. X minus 4's go away. X minus 5's go away. Leaving me with x plus 2 over x plus 3. Now, sometimes things get a little complicated and you are given 3 terms. We're going to approach it in the exact same way we've done all of these multiplication problems. One thing I do want to remind you of is if you have a problem that's not written as a fraction, you can always write it as a fraction by writing it over 1. So that's what I'm going to do for this problem. So I went ahead and I'm starting to combine steps, starting to pick up the pace a little bit. So x plus 1 over 1 times the factored form of my numerator is x minus 1, x plus 3. The factored form of my denominator is x plus 1, x minus 1. Now, this division symbol is telling me I'm going through the process of keep, change, flip. I've kept the first fraction exactly as it is. I've changed to multiplication and I've flipped my second fraction. So now I have x over 2x plus 3. Now we have to write our undefined values, and I'm going to go through and I'm setting each denominator because we like to think of this as one big fraction. Each denominator not equal to 0, and the numerator that comes after the division sign not equal to 0. I usually say the second fraction, but in this case it's really the third because of the placement of our problem. So x cannot equal to 0 means x cannot equal to 0. 2x plus 3 or 2x plus 3 means x cannot equal -3. X cannot equal plus or minus 1, and this is not going to generate any value that is undefined. So I have my undefined values written down. Now I'm going to start the cancellation process. So I have x plus 1, x plus 1, x minus 1, x minus 1. I have x plus 3, x plus 3, and I'm left with x over 1 times 2. So that gives me x over 2 as my final answer. One last thing I want to cover is remember in order to cancel, it has to be in the top and the bottom. Say, for instance, if I were to have an x here, I could not cancel out this x with this x. It has to be numerator and denominator. It can't be having the same thing in the numerator in order to cancel, or the denominator. I just wanted to remind you of that.